Today I will discuss with you the velocity, the variable velocity, and the instantaneous velocity, like these terms. And then I will discuss with you the acceleration, average acceleration, and the instantaneous acceleration, and then equations of motions for constant acceleration, and the last will be the free fall motion. Okay. So I am starting this chapter number 2. In chapter number 2, so we have already discussed, you remember that we have discussed position, distance, displacement, speed. And then we are discussing, now I want to discuss with you the velocity again. So velocity was what? Velocity was that displacement over time, or you can write delta x over delta t. So this is equal to xf minus xi over tf minus ti. So this is the formula which we are using to find the average velocity. Okay. So when we are saying the average velocity, so remember, this is very important. We are measuring the velocities between two times. Two times mean one is initial time. Suppose initial time is 1 second and the final time is 3 seconds. So between these two times, we are putting the values of TF and TI here, and also the TF 3 second, we will find the XF, and then at TI is equal to 1 second, we will find the XI. Okay. So we will put the values and solve it and get the value of this V average. This is one thing. And this is about the average velocity. Okay. So the units is meter per second, and length t raised to power minus 1 will be the dimension of the velocity. One thing. The second thing is variable velocity. Variable velocity mean what? And the constant velocity. And constant velocity mean what? So if a body is moving from A to B, then B to C, then C to D, suppose the distance is 10 meter, 10 meter, and 10 meter. Okay. So here he is taking a time 2 seconds, then 5 seconds, then 10 seconds. So what is the velocity here? 10 divided by 2 is 5 meter per second. 10 divided by 5 is 2 meter per second. 10 divided by 10 is 1 meter per second. So it means the velocity is changing for every interval of time. Although the distance is same, the displacement is same, but the velocity is changing. So we can say that velocity is variable from point A to point D. So this is called variable velocity. The distance is same, but the time is different. Okay. One thing. But if we got the same value like 5 meter per second here and 5 meter per second here, 5 meter per second here, then we can say the velocity is constant. So this is called constant velocity. So I think now you understand that what is the meaning of the variable velocity and what is the meaning of constant velocity. Okay. So if the velocity is variable, then you can add the distance 10 plus 10 plus 10 total distance or displacement divided by total time. You can find the speed like in this way. Okay. So this next is the most important is V instantaneous. This is called instantaneous velocity. Instantaneous velocity. So instantaneous velocity mean what? If we have this displacement time graph, so the displacement time graph is like this one. It is curved. This is A point, this is B point, and this is C point. So if you want to find the average velocity, first I'm starting from the average. If you want to find the average velocity between A and B, it means this is your Ti time and this is your Tf time. So the average velocity between A and B will be here. Okay. This is, suppose my point is D. If you want to find the average velocity between A and D, it will be here. If you want, this point is suppose E. If you want to find the average velocity between A and E, it will be here. So the point is going close to A. It means if you want to measure the time, this time becomes very, very small, very, very small. Okay. So when the time is very, very small, then we average velocity, we write it limit delta t approaches to 0, and this is equal to delta x over delta t. So we can write this one like this one, and this is not our average velocity. This is our instantaneous velocity now, because the time is very, very small. So you are measuring actually the velocity at one particular time, So if only one time is given, then this is your instantaneous velocity. But if two times are given, like Ti is this one and Tf is this one, then it means you are measuring the average velocity. So this equation is called instantaneous velocity, and we can write this equation in terms of mathematics. So V instantaneous is equal to dx over dt. This is the derivative of the displacement. So if you are taking the derivative of the displacement, then you are measuring the instantaneous velocity. But if you are not taking the derivative, you are just T1 time and T2 time, you are taking two times, and you apply the formula, this one, V average is equal to XF minus XI over TF, TF minus TI. It means you are measuring average velocity. So I think you understand that when you are measuring instantaneous velocity and when you are measuring the average velocity. So this is an important concept. So I'm giving you one example here. Let's see the example. The example is suppose we have x is equal to t cube minus 6t square. So this distance or displacement is given in the form of this equation. Okay. So if he is asking find the velocity, find velocity at t is equal to 1 second. So it means he is asking the instantaneous velocity. So what you will do? Dx over dt. You will find the derivative. So this derivative will be t square minus 12t, like this one. So what you will do? So you will put here at t is equal to 1 second. You will put this value and solve it. And the answer is minus 9 meter per second. And this is your instantaneous velocity. But if he is asking that the initial time is 1 second and the final time is 4 seconds, find the velocity. Find the velocity. So it means you are finding actually the average velocity. So average velocity is what? Average velocity is xf minus xi over tf minus ti. So xf mean what? You will put here tf. How much value? 4. 4 and solve it. And this is your tf. Then you will put at t is equal to 1. Here t1. This is your xi. So you have xf, xi, you know the tf and ti, and putting the values here and solve it and get the answer. This is your average velocity. This is your instantaneous velocity. Now I think you understand this concept. Yes, any question? Okay, so after this concept, the concept of the average velocity and the instantaneous velocity, the next concept I want to give you, the acceleration. So acceleration is what? So remember, acceleration is a vector quantity and it is defined as the change in velocity over time. And normally at high school physics, you are defining by acceleration a rate of change of velocity. Change of velocity is called acceleration. But here the words are very important. Every word has some meaning. Meaning mean velocity, you can write the velocity d over dt like this one is no problem. But when you want to write the acceleration, you always write vf minus vi over t or tf minus ti. But this change is very important. You cannot write acceleration is not equal to v over t. This is wrong. But you can write velocity is displacement over time. But here you cannot write like this. This is okay. This is wrong. So if I am asking, here I can explain this one. If I am asking, what is the direction of the velocity in this equation? You will say the direction of the displacement. You can say the direction of the change in displacement. But if I want to ask, what is the direction of the acceleration? You cannot say that the direction of acceleration is the direction of the velocity. No, you always said that direction of A is the direction of change in velocity. The direction of change in velocity. I will explain you in free fall motion. You can understand this concept in a very good way. Okay. So acceleration is this one is actually the average acceleration. So the same like in the velocity, you know that velocity we have defined that this is average velocity is equal to what? Xf minus xi over tf minus ti. Okay. And v instantaneous is what? V instantaneous is dx over dt, derivative of the displacement. But in acceleration, same thing, average. Average acceleration is vf minus vi over tf minus ti. And what is the instantaneous acceleration? So instantaneous acceleration is dv over dt. Here dx over dt, here dv over dt. And this dv over dt, you can write d2x over dt square. The double derivative of the displacement is also called acceleration. And this acceleration will be instantaneous acceleration. So instantaneous acceleration means you are finding the acceleration at one particular time. But average acceleration means you are finding the acceleration with 2 times ti and tf. Ti time and tf time. So this is the concept which I want to give you. Okay.
So can you explain instantaneous velocity, doctor?
Again, please. Yes.
Can you explain instant acceleration again? I didn't understand.
Instantaneous acceleration.
Yeah.
Yes. Instantaneous acceleration mean this one. Okay, I just give you one example. Okay, let's see. Suppose we have this equation, v is equal to 50 minus 5t square. You want to find the acceleration at t is equal to 1 second. So this acceleration will be instantaneous. How you can find? You will find the derivative of this one, dv over dt. So dv over dt is, this derivative is 0 and this is minus 10t. 5 multiplied by 2, 10 and t. So this is your instantaneous acceleration. So minus 10 into t. T is 1 second, 1. So this is your acceleration. And this is instantaneous acceleration. If he is giving 2 times mean t1 time is 1 second and t2 time is 3 second. And then he is saying, find the acceleration. Find the acceleration. What you will do? First, you will find the at v2 and t1, v1 or v2. Okay, let's see in the next page. I am writing the same equation, that v is equal to 50 minus 5t square. So if the t1 time is 1 second and t2 time is 3 second, so find the average acceleration. What you will do? You will find the a average is equal to v2 minus v1 over t2 minus t1. So v2 will be what? So you will put 3 second. So 50 minus 5 into 3 square. And this is 50 minus 3 3s are 9. 9 multiplied by 5, 45.
45.
So this is 5 meter per second. Okay. So you will find the v1. 50 minus 5 into 1. So this is also 45. So luckily, luckily, this is equal. This is equal. So it means if sorry, not equal. This is 5 and this is 45. Sorry. So what you will do? V2 is 5 minus 45 divided by 3 minus 1. So answer will be what? Minus 40 over 2. This is equal to minus 20 meter per second square. Okay. So in this way, you can find the average acceleration. But if you want to find the instantaneous acceleration, what you will do? You will find the derivative of this one, dv over dt. So dv over dt is minus 10t. So he will ask you the find the acceleration at one particular time. At one particular, this is I'm stressing, only one time is given. 1 second, 2 second, 3 second or 4 second. He will not give you two values of the time. He will give you only the one value of the time. This is my point. Okay.
Understood.
Okay, after this, one thing is very important, and that is the direction of the motion. Direction of motion. Either the body is moving in the right side or it is moving in the left side. Who will decide? Which quantity will decide? Okay. So only velocity will tell us, not speed. Velocity will tell us the direction of the motion. The direction of motion. The body is moving in the right side or it is moving in the left side. So if the V is positive, it means it is moving in the right. If V is negative, then it is moving in the left. So remember this one, you can only judge or guess with the velocity notation. It is positive or it is negative. Otherwise, you cannot measure. Okay, after this, one more concept, which is very good concept. If he is asking, find the velocity for the 3rd second. I'm writing the 3rd second, 4th second. So here 3rd second, or 3 seconds are different things. 4th second or 4 seconds are different things. Understand this one. Understand this one. If I'm writing here the 5th second doesn't mean that it is 5 seconds. So if you want to find the velocity for the 3rd second, what you will do? Surely in the data, he will give you the value for the 2 second and the value for the 3 second. So for the 3rd second, the velocity will be what? Velocity at 3 second minus the velocity at 2 second. And this is your 3rd second velocity. If you want to find the velocity at the 4th second, what you will do? You will find the velocity at the 4th second minus the velocity at the 3 second. I'm saying 3 second. I'm not saying the 3rd second. 3 second. Understand? So you must understand the 3rd, the 4th, the 5th second. Okay. After this, at high school physics, you have already studied the equations of motion. Equations of motion with constant acceleration. With constant acceleration. So here the acceleration is constant. We are not discussing variable acceleration. We are discussing variable velocity, but acceleration will be constant. So for constant acceleration, you have already studied at your high school physics the equations of motion. Vf is equal to Vi plus At. The body is moving on a straight road. Either it is moving in this way or it is moving in this way. We are applying this equation. We are applying the equation 1 over 2 At square. We are applying the equation Vf square minus Vi square. We are applying the equation V average multiplied by time. Here you can see there is no acceleration in this equation. Here is acceleration. Here is acceleration. Here is acceleration. This is acceleration. This is acceleration. This is acceleration. But here is no acceleration. If there is no acceleration, then this means that average velocity is Vi plus Vf over 2. So this is the formula to find the average velocity if there is no acceleration. Okay. So we are using this equation, or this equation. But in your book, you will see that this equation is written like this one. Xf minus Xi is equal to Vit plus 1 over 2 At square. And this is 2a Xf minus Xi is equal to Vf square minus Vi square. So here Xi and Xf mean what? If the body is starting from 0, so it means Xi is 0. If the body is starting from, suppose 2 seconds, so it is starting from, it is already covered 2 meter distance, not 2 seconds, 2 meter distance, it is already covered. So your initial value is 2. You are not, you will not use here 0. So that's why the equation is written like this one, or the equation is written like this one. No, it depends on the problem, what type of problem is giving, and according to that problem, you have to put the value. Okay, after this, we are moving towards the free fall motion. Free fall motion. So in free fall motion, this is also you have studied at high school physics. The body is falling freely under gravity, or the body is throwing upward vertically. This is vertical motion. Vertical motion. Okay. So if you are falling the body from here, so remember the initial velocity is 0 and the final velocity you can find, and how much time it will take to fall down, and what is the height or the distance. Okay. So All these things are very important. But before this one, you know the concept. If the body is moving up, you normally take minus g. If the body is moving down, you normally take plus g, because this is against gravity. This is against gravity, and this is with gravity. So that's why you are using this notation. But remember, very important, remember, the direction of G direction is always downward, always downward. G direction is always downward because G is due to gravity and gravity is downward. Okay. But here we are using the concept of this, and this is for the simplification to solve the problems. Otherwise, G is actually, A is actually minus G, always minus G. Either the body is moving up or it is moving down. It is minus G. But to simplify the problems, we use this notation. If we are using this notation always, then we have to, X is taking positive in the upward direction and V is taking positive in the upward direction. And in the downward direction, X is negative and V is negative. Then we will use this concept. But you should do this job with this notation. I think it's better for you because you are already familiar with these notations. So let's see, the body is moving, falling downward. If the body is falling downward, this is free fall motion, free fall. So here is the ball, it is moving down or it is falling down. Okay. So initial velocity is always zero and final velocity you can find, time you can find. Okay. And h distance you can find. So if the body is falling freely, what will be the VF? So VF is equal to VI plus GT. So VF is equal to, this is 0, okay, plus GT. Because it is moving down, G is positive. We are taking G positive. So VF is equal to GT. So this is the relation to find the value of V. So if you want to find the value of T and you know the value of VF, you apply this equation and find the value of T. And similarly, if you want to find H, so what you will do? So H is equal to VIT plus half GT square. So H is equal to VI is 0. So this factor is 0 and answer is 1 over 2 GT square. And this formula you will use in your practical lab when you will study this experiment that is called free fall motion. Okay. In free fall motion, you will use this formula and find the time or find the distance. So if you know the height, you can find the time. If you know the time, you can find the distance. So the time will be what? T square is equal to 2h over g. And if you take the under root of both sides, this will cancel with this one and time will be 2h over g under root. So you can apply this formula if you know the height to find the time. So if you know the velocity to find the time, you can use this formula. So this is free fall motion. The body is moving down. If the body is moving up, then what will be the situation? See in the next page. Now the body is upward motion. I am taking the case of upward motion. In upward motion, the body is moving up like this one. Here we are giving some velocity and at the maximum height, this is the maximum height, the final velocity will be 0. What will be the G value? G value is constant, not 0. Don't say 0. G value is constant. Okay. So for upward motion, VF at maximum height, only at maximum height, VF is 0. Here it is not 0. Here it is not 0. So you can apply the formula that VF is equal to VI. Upward, body is moving upward. So A is equal to minus G. So minus GT. So you can apply this formula. 0 is equal to VI minus GT. Okay. So T is equal to VI over G. So this is the time to reach the maximum height. Time to reach maximum height. This is the time. So what is the time to reach back in the ground? I mean that it reaches here and then come back. So the same time. If this is upward time and this is downward time, so it is VI over G. So the total time will be what? So total time will be VI over G plus VI over G, and this is equal to 2 VI over G. This is the total time. Now you can find the distance or the maximum height by using the formula the same. So VF square minus VI square is equal to 2GH. Here VF is 0, this is 0. So minus VI square is equal to 2 into minus G into H. So minus minus plus. So H will be what? H will be VI square over 2G. So in this way, you can find the value of H. H mean the maximum height. So this is the vertical motion. So either the body is moving down or it is moving up. You can apply these formulas or these equations of motions frequently and very easily. So in this way, you can solve your problems. Yes, if you have any question, you can ask me. So what we have discussed today, we have discussed the V average, and that is XF minus XI over TF minus TI. Then we have discussed instantaneous. Instantaneous is what? dx over dt, derivative of this one. Then we have discussed a average acceleration. Average acceleration mean what? Average acceleration mean VF minus VI over TF minus TI. Then we have discussed instantaneous acceleration, and this is dV over dt. So instantaneous, either this or this at one particular time. But the average value of this one, they have given you the value of T1 and T2. 2 times will be given. Okay. So this is the concept which I want to give you. So in the next lecture, I will discuss with you the graphical pictures which I have already discussed. If we have this displacement time graph, what will be its velocity time graph? What will be its acceleration time graph? Okay. So if the displacement time graph is here, so what is the slope? Slope is constant. So the constant slope mean the velocity is constant. So the constant velocity is in the positive direction. So we will make the line like this one. So if the velocity is constant, the acceleration will be, if velocity is constant, the acceleration will be what? Acceleration will be zero. So zero line will be here. Understand? Zero line will be here. Clear? So all these graphs we will discuss in the next lecture. If you have any question, any problem, you can ask me. So today I will send you the video lectures. Okay.
Okay.
Sure.
Sir, I have a question.
Yes.
Is there anywhere we can practice some questions?
Yes, we surely we will practice. Why you are worried? Don't worry.
Thank you.
Don't worry. This is my responsibility. Okay. We will make practice. Okay. See here in this chapter, you have discussed the displacement. Okay. You have discussed the distance. You have discussed the speed, average speed. Okay. You have discussed the velocity, average velocity, instantaneous velocity, acceleration, average acceleration, instantaneous acceleration. Okay. Then you have discussed the equations of motion, the fourth equation of motion. Then you have discussed the free fall motion. And last, we will discuss the graphical pictures. These are the articles which we have studied in chapter number 2, and we will solve the problems about the speed, about the displacement, distance, velocity, acceleration, equations of motion, free fall, and graphical. Graphical, I just explain you in the next lecture, and you can apply it and make an other graph to watch this one if you know the rules. So I will tell you the rules. Yes. Any question?
No, thank you.
Study yourself, because you have seen, because I am teaching this course from the last maybe 6 years, and many students, because now the classes are online, so many students have their own some notes in the market. So you should solve that problems. Those notes are not bad. Those notes are good, but understand them with concepts and make practice. And surely I will make practice here, and you should make practice with those notes. Those notes are okay, good, but understand them with concepts, and the concepts I have given you. So when you see any equation here in this chapter, which I'm thinking that if you see any equation, x is equal to suppose 3t square plus 5t, like this one, and he is asking find the velocity at t is equal to 3 seconds, suppose, it means you are finding the instantaneous velocity. Clear concept? Okay. If he is saying that find the velocity at t1 is equal to 1 second and t2 is equal to 5 seconds, it means you want to find the average velocity. Okay. First, you will find the x2 and then x1, and then divided by t2 minus t1 and find it. This is one concept. And the second concept same exists in the acceleration case. Okay. In the free fall case, I already explained the ball is falling or the ball is going up, how you can solve the problems. And the speed problems, I already explained you that if the body is having the different speeds, but the same distance, how you can solve this problem. In the first lecture, I have explained this one. And similarly, I have explained you what is the concept of position, what is the concept of distance, and what is the concept of displacement. You already know this one. So if you have clear this concept, I am 100% sure you can solve this problem. Okay, if you don't have any question, then inshallah see you in the next lecture, and I will explain the graphical pictures of this in this chapter.
Thank you very much.
Okay, thank you. Assalamu alaikum.
Wa alaikum assalam.